Team, we're going to go ahead and look at the next part of the lesson, and basically we're going to look at two lines and see what happens when we multiply it and kind of explore some of the things that are behind closed doors. So let's jump on in. All right. Consider the quadratic function you created to represent the cross-sectional area of the rain gutter in a previous lesson. Let's just kind of look at the situation that's presented. And it's basically saying that, hey, there's this function, h of x. It's right here. I have this other function, L of x. It's right here. Both of those are graphed. I'm going to go ahead and switch the color of these lines in order to kind of facilitate which one I'm talking about. Now, you might be able to identify which line is which based on your previous content knowledge of the equation of a line. Notice in h of x, when it equals x, the coefficient in front of the variable is a positive 1, meaning it's going to be increasing. Here in this line, it's going to be decreasing because the slope is negative. Okay, what we're going to do now is look at the first problem. We need to label the zeros of each function with open points on the coordinate plane and on the number line below the coordinate plane. So notice this green line has an x-intercept of 0. You can prove this algebraically. From above, I know that the function h is equal to x for all x-intercepts, negative or positive. It is going to have a y value of 0, meaning I switched the entirety of h of x with 0 equals x. Well, that equation answers itself, meaning that the solution is going to be 0, 0. Okay, one of my zeros is here. My other 0 from my other line is here. But notice how it's between 4 and 6 and it's not exactly on a grid line. To algebraically find it, I would go ahead and use L of x is equal to negative 2x plus 8.5. So I'm going to go ahead and do the same thing. All x-intercepts have a y value of 0. And I'm going to go ahead and solve this equation using inverses. I'm going to go ahead and subtract 8.5 from each side. This is going to result in 0 minus 8.5 is equal to a negative 2x. Here, I'm going to divide by negative 2. And when I divide by negative 2, I'm just going to flip it to write it out as x is equal to a positive 425. To help split it up, I like to think of it 50 as 50 cents. Half of 50 cents is 25. So it's about here. Notice this point would be x is 4.25. What is the y value? The y value of all x-intercepts is 0. Hence, it matches my graph. Number 2. It says consider the three regions and whether the output values of the product h of x is positive or negative. Label the number line accordingly. All right. So remember my colors. H of x between all right, so the three regions is A. Let's look at region A. Region A is going to be this space. Do you see how region A does not touch the 0? It goes all the way to the 0. So here we're going to be talking about the behavior of the lines in region A. Notice that h of x is below the x-axis. So it's going to be equal to some negative number. Okay. Now, Let's look at L of x. You might be wondering, the line isn't in region A. Well, actually, I have to continuously extend, but the line does eventually reach region A. I hope we see that in region A, the blue line is above the x-axis, meaning L of x is going to be equal to some positive number. If I'm trying to figure out the product of these two lines, if I'm multiplying h of x and I have to multiply it by L of x, it's asking myself, what is a negative times a positive? Well, this is going to have to be a negative number, meaning it's going to be below the x-axis. I'm going to repeat this again. This was for A. Let's go for B. H of x in region B, between these two zeros. So, region B, well, what is the behavior of the green line, h of x? Notice how between 0 and 4, the line is above the x-axis, meaning it is a positive value. Notice L of x in the region between 0 and 4 is equal to a positive number. That means if I were to take my two lines and multiply them together, that would result in a product. A positive times a positive is a positive. So it would be above the x-axis. Continuing this party, for region C, that is going to be the region that is after 4.25. Okay, region C. Well, what is the behavior of line h of x? It is above the x-axis. I see it right here. It is above, so it's going to be positive. Notice below, L of x is below, so it's going to be negative. So what is the product? What is h of x times L of x? A positive, or a negative times a negative is a positive. Oh wait, no, I messed that up. H of x is totally positive. H of x is above. So it's below the x-axis. So voila, this is literally the answer to B. So determine whether the outputs of the product functions is positive or negative. The graph is basically going from this. So let's go ahead and formalize some of these words. H of x times L of x. All of this would be here. Case A, case B, and case C. All right, you get the idea. I would move it here. So what we're also going to do is we're going to go ahead and do it for a specific value. I'm going to choose a simple x value in a region. So we're going to go ahead and go to case B. And the reason being is I'm going to pick when x is 1. Okay. Look in here when x is 1. When the x value is 1. Notice how the output is 1. I'm going to go back. I can figure out this algebraically. If I look at my original function, h of x is equal to x, which means when I put 1 in, it's just going to be 1. Likewise, L of x is going to be negative 2x plus 8.5. When L is 1, it's going to be negative 2 times 1 plus 8.5, which would mean the output when X is 1 is going to be 6.5. If I go to my graph, when X is 1, notice how it's about 6.5. Notice how the algebra matches my graph. And what they're asking is, what is h of x times L of x? H of x was 1 times 6.5 is going to result in a positive 6.5. Remember above we said case A was going to be negative. Case B, case C, isn't the point when x equals 1, isn't that in region B? Notice x is equal to 1. It is in region B. It had a product that was positive. Basically, this is proof of what we were doing in part A.